we start soon, we can finish, right? All right, so we're going to be doing rational expressions. And so a rational expression is just a polynomial over a polynomial. This is just how we write it, where the top one's a to the n, just same as before. Where both of these exist in the reals, you can have polynomials where you have the coefficients be complex, but we won't be doing that in this class. But the first thing we want to address is domain. Domain is one of those things that gets harped on pretty hard when we're doing when we do when you take a class normally in calculus. It comes up a lot that if you don't understand domains, you end up doing stuff you're not supposed to do and get wrong answers. So that's just one of those things that come up. So the domain is of an expression are all the allowable inputs, everything you can put into it. So things that make sense to put into it. For now, we're going to say that the square root of x, if I'm going to take the square root of x, I need x to be greater than 0. And if I say x is greater than 0, hold on, let me open up something real quick. Own benefit. We need x to be greater than 0. Oh, no, greater than or equal to. I can take the square root of 0. Square root of 0 is 0. But most of the time, your computer is going to want you to put it in um, for your homework and stuff. They're going to want it in interval notation, so it'll be a bracket to infinity. Okay. A polynomial. A polynomial can accept any x. So I can put in negative 2x. I can put in the square root of pi. I can put in whatever I want here, right? And then you can compute out a number. And so polynomials can take everything. And so this is all reals. In fact, let me put a little side note right here. So a polynomial, any polynomial will be all reals. If I have a rational expression, so let me just put, let me just draw it this way. So if I have stuff up top, stuff down below, this down below cannot equal 0. So if I have a rational expression, the bottom can't equal 0. If I have a square root, whatever's here has to be greater than, it has to be, oops, whatever here has to be greater than or equal to 0. And then if I have 1 over a square root, whatever is here has to be strictly greater than 0. And so these are the three things that come up the most. If you have a rational expression, what's on the bottom can't be 0 because we can't divide by 0. If we have a square root, currently we're not allowing the input here to be imaginary, so that's why we said it's greater than or equal to 0, and if I have 1 over square roots of that. So here, these two are polynomials, so these take all real numbers. Or if you're going to write an interval notation from negative infinity to infinity. Here, I have a rational, so what's down on the bottom cannot equal to 0. So here I'm going to set this plus 6 cannot equal 0. And solving for something that can equal to 0 is just as easy as solving for something that does equal for 0. You just change what the rules are. So here I just factor this. So this would be x minus 2, and this would be x minus 3. Cannot equal 0. So that means x cannot equal 2, and x cannot equal 3. So if you're solving a can equal is the same thing as solving an equal, you just always have an extra slash. In interval notation, this would just be from minus infinity to 2, union 2 to 3, union 2 to, or 3 to infinity. Okay. All right, so let's look at what we have here. Let me actually, no, this is fine. Let's do this. Yeah, so let's go ahead and do this. So here, we cannot have this equal to 0. So 3x plus 2 cannot equal 0, right? That means x cannot equal, move this over, so that'd be minus 2/3. Okay, so here I can't divide by 0, so x cannot be negative 2/3. But here I have a square root up top, so I need to deal with this. So this has to be, x has to be greater than 0. But notice that x being greater than 0 already, or greater than or equal to 0, already discludes or does not allow the negative number. And so at the end of the day, the only answer, stuff so I can make it clear. The only thing we need to do here is 0 to infinity, because this negative 2/3 already isn't in the domain of the square root. Now the same thing here. I'm gonna, if I have a square root on the bottom, I have to make this strictly greater than 0. So x plus 2 is strictly greater than 0, because I can take the square root of a 0, but I can't divide by it. And so that's why we throw away that one. Here, we'll just move the 2 over and divide by the 3. And then at the end of the day, we'll get negative 2/3 to infinity. Okay. So the main, when you're dealing with the main, usually if it's a polynomial, anything is allowed. Irrational, just take whatever's on the bottom, set it not equal to 0. And that figures out what two numbers you need to throw away, or x numbers, or what numbers you have to throw away. Here, this was 2 and 3. Here was the negative 2/3. For square roots, we're forcing them to be positive right now, or non-imaginary. And so you have to have whatever the value is here to be greater than or equal to 0. And if it's 1 over that, well, the square root has to be greater than or equal to 0. But if the square root was 0, you're dividing by 0. So you just have to make it strictly greater than. Okay, hopefully that makes sense. You'll see a couple square root problems or domain things on the exam and in the homework. All right, let me take a drink. And let's do the next one. All right, properties of fraction. So I rewrote the properties of fraction for you again, since we need them. All right. So we can simplify rationals by canceling. And so we're using this property right here, the cancellation property. But in order to do this, we're going to have to, I think I left myself a little extra room, but that's okay. We're going to have to factor. So now that we've done all our factoring, we can factor this. This is the difference of squares. So this would be x plus 1. This would be x minus 1. And so when we're simplifying this, we have the same factor. Notice I can cancel factors, but I cannot cancel terms. So it has to be a factor. And what do I mean by that real quick? A factor is something that is multiplied by everything on top and everything on bottom. A term, this is a term, this is a term. So let's pretend I had a plus x here, or a minus x here real quick. I cannot cancel this plus x and this minus x. Then I'm canceling terms. That is not allowed. But seeing how I have an x plus 1 and an x plus 1 here that's multiplied by everything up top, that is allowed to be canceled. And this simplifies just to 1 over x minus 1. And just real quick, the domain of this would be everything except x equal to 1, because if x equal to 1, this would be 0. All right, so let's factor this up top. So here we can factor up top. This becomes x. This is difference of squares, so it would be x plus 1, x minus 1. Here we just do our normal factoring. And our normal factoring gives us x plus 2, x minus 1. So here I now have a factor of x minus 1. X minus 1, I can get rid of it. And this simplifies to x plus 1, x plus 2. And that's it for this page. So grab a drink because you got to write it down. Here, I'll add you in real quick. I got you, my friend. I'm not going to say your name because we're in the recording part, but I got you. All right. Yeah. It's much nicer for your internet to be down than your car being down because the car being down is usually a lot more expensive when we're in person, when people don't get there when they want to. All right. So let's do this. So we're going to simplify. Um, so we're going to simplify by multiplying and dividing. And so this is the same thing here. So here, let's go ahead and do this. So the first thing I want to do is actually do this multiplication step. And so here I'll have x squared plus 2x minus 3 times 3x plus 12 all divided by x squared plus 8x plus 16 x minus 1. And then the next thing I'm going to do is factor. So if I factor this, this becomes x plus 3x minus 1, 3x plus 12. And then here, if I factor this, this is x plus 4 squared, but I'm going to write it as x plus 4, oops, x plus 4, and then x minus 1. Oops, I could have done one more thing. Let me do that now so I don't run out of room. Sorry for that. Can I factor something out of here? And the answer is yes. I can factor a 3 out. So I can have a 3x plus 4. There we go. All right, now these are all factors. And so it's a single term up top, a single term down below, but I can get rid of factors within that. So here I can get rid of this and this. I can get rid of one of the x plus 4s and this. And so I have 3x plus 3 over x plus 4. And this is about as simple as I can get it. So we're going to leave it right here. Here we're going to do this one. And we're going to do the same thing here. But now this time we are going to x minus 4. We're going to flip and multiply. And so this will be x squared plus 5x plus 6 all over x squared minus 4, x squared minus 3x minus 4. So here I just flipped and multiplied for the division. And then I'm going to factor. So up top I'll have x minus 4. This will factor into x plus 2, x plus 3. Does that work? Yeah, that works. Again, how I got that is I take the factors of 6 and I want them to add up to 5. And so positive 2 and positive 3 adds up to 5. So that's how I got that. This is a difference of squares, so this will be x minus 2, x plus 2. Here I have x, so negative 4. So negative 4, I want negative 4 and positive 1. Yeah, that works. So it'll be x minus 4, x plus 1. Okay, let's see what we can cancel. There's an x plus 2, x minus 4. I think that's it. So here we'll have x plus 3 on top times x minus 2, x plus 1. Okay. All right, so all we're doing here is just simplifying rational expressions. You'd be amazed of how useful this is in calculus and how not super well done it's done most of the time. Let me leave it here so you guys still can copy. All right, let's simplify this. So here, if we're simplifying this, we'll have to get a common denominator. And so in this case, if I have x minus 1, x plus 2, I'm going to have to multiply this. So I'm going to multiply by 1. Now my 1's going to look a little interesting. It's going to be x plus 1, x plus 2, x plus 2 over x minus 1. And the reason I multiply it this way, x plus 2, x plus 2, this is just really a 1, right? No matter what x is, I'm multiplying by 1. And so I can safely multiply by that. But this will get me to my common denominator, And here I'll have to multiply by x minus 1 over x minus 1. So here's another 1. When I do that, let me just do this real quick. So I'll have 3x plus 6 over x plus 2, x minus 1, plus x squared minus x over x plus 2, x minus 1. And then I can perform this operation. And so here I'll have 3x plus 6 plus x squared minus x all over x plus 2, x minus 1. And then I can simplify up top. Let's bring the x squared out front. 3x minus an x will be minus plus 2x, sorry, plus 2x plus 6 all over x minus 1, x plus 2. Okay. And so when you're dealing with rationals and adding them up, it can be quite a hassle. Just can be. All right, so let's look at this one. So here in B, I have very simple things up top, but I have complex things down below. And if I have a lot of factors, the first thing I like to do is go ahead and factor it real quick. So here I'll have this as x plus 1, x minus 1, and then here's x plus 1, x plus 1. And the reason I want, oops, this is a 2. Sorry about that. The reason I want to do this is here I have x plus 1, x plus 1. Here I have an x plus, read it, x plus 1, x minus 1. Well, in order for this to have the same denominator, all I have to do is add an x plus 1 here over an x plus 1. And then here, I just need to add an x minus 1 over an x minus 1. And then each of the denominators will be the same. So everyone see why I'm adding an x plus 1 over here and x minus 1 over here? Any questions on that? Just real quick. No, I appreciate you writing no. Usually I just look at your eyes, right? If you're kind of glazed over in boredom, they got it, right? If you're glazed over in confusion, you don't. But I can't do that right now. So here we go. So here we get 1 over, we get x plus 1 over, and I'll go ahead and write it back together. Squared minus 2x. I'm going to go ahead and pull in the negative sign just to make my life easier. I usually do this. Negative 2x plus 2. All right, and then here we can just do the addition and call it good. I'm not going to, I'll skip the extra steps. So here we'll have 2x plus a negative x will be minus x, or negative 2x plus an x is minus x, and 1 plus 2 is a 3. And then we'll have this all over x minus 1, x plus 1 squared. Okay, and that's it. All right. I'll leave that up for 2 more seconds and then we'll go to the next page. All right. So here's where things get kind of fun. So now we want to get rid of compound fractions. So how do you do this? Well, the first thing I would do is I would get rid of the compound fractions in the top and the bottom. And how would I do that? I'd multiply here. Let me zoom on in to make my life easy. I lost my blue. make my life easier. And so here, I'm going to multiply this as my y over y. Why? Because I need to get a common denominator here, and then here I'm going to multiply this as x over x. So if I do that, the top part becomes x plus y over y, because this becomes y over y divided by, here we'll have x minus y over x. Did I lose anyone here? If you do, write so do so in chat. I'm going to keep going, assuming I haven't, but please, you can send me a secret message, right? Just say, message me directly. That way, no one knows you don't understand, except for me, but I don't care. I'd rather you speak up. All right, so if I do this, what am I going to do? Well, now I'm just going to flip and multiply. So here, and then I'm dividing by this. That's what this bar means. It means divide by. So I'm going to flip it and multiply. And then once I do that, I'll zoom out again so I don't have to be so close in. This equals x times x plus y. This is y times x minus y. And that's about as simple as you can get it. Okay. All right, now this secretly is calculus. In fact, this is how you compute a derivative of 1 over x. That's literally what we're doing. I read that some of you guys took an AP course and didn't do amazing at it for calculus, or didn't sign up for it. So you should recognize this. This is the limit as we take h goes to 0. If I take limit as h goes to 0 of this, I will find the derivative. Does that look vaguely familiar to anyone as that? Maybe? No? Okay. Yeah, okay. So how do we deal with this? This is where a lot of people got stuck in calculus, and so that's why I specifically added this problem. So let's deal with it not as a calculus problem, but just as simplifying compound fractions. Okay. Well, in order to do this, I need to multiply what? Well, here I need I need an a and an a plus h, right? So here I have an a plus h and an a. So I need to multiply this. Let me do this over here so I have room. I'm gonna have a over 1 over a plus h minus 1 over a, and then I'm gonna add an a plus h over a plus h. All right, now let's do this. So now we do all over h. So when I simplify this, I get a over a plus h times a minus an a plus h over a plus h all over h. So here, I'm going to get rid of the compound fraction by adding the two fractions. Here I have an a plus h. I get the same thing. Now I'm going to add up top. So an a minus an a is nothing. So I have an h over an a plus h all over h. Oops. This is negative. This negative needs to be chucked into here. That's why I usually write it in not as this, but as this. I usually check through the negative, and so I put a plus, a minus a, plus, or minus h. That way I know to keep the negative. All right, so here, so what do we do from here? From here, we just go ahead and flip and multiply. So I'll do that. So I have minus h over a plus h times 1 over h. Now I can cancel out the h. um, a negative 1 over a plus h. Okay. Now, if I was taking the limit real quick and set h to 0, this just becomes minus 1 over a squared, which is the derivative of 1 over a. So that's for calculus. We're not going to be doing that, but that's just real quick where that comes from. Yes, I can cancel out the negative h with the positive h and just leave the negative sign here. So let me rewrite this real quick. I could write this as minus 1 times h, and then I can safely cancel out the h if that makes you a little bit more careful. So because I can split the negative 1 from the h. All right, so let's talk about complex radicals. Let me just zoom out real quick. That way you can still write if you need to. So given a radical expression, a plus b square root c, the complex radical, the conjugate, conjugate radical is a minus b square root c. And that way, if you multiply it together, it gets rid of the radical expression. This is useful for doing some things. So let me zoom on in. We'll go ahead and do it. All right, so here, a lot of times you don't want the radical in the bottom for who knows what reason. I don't mind them, but a lot of people do. No. So here you're just going to multiply top and bottom by the complex radical. And so here, it'd be the conjugate, not complex, the conjugate radical will just be a 1 minus the square root of 2. And what you do to the top, you must do to the bottom, aka you have to multiply by a 1. So if I do this, I get 1 minus the square root of 2. And then here, I get 1 plus the square root of 2, 1 minus the square root of 2, so it equals 1 squared. So 1 squared is 1 minus, there's no coefficient here, so there's no coefficient here, minus 2. So this would be minus 2. So this is equal to 1 square root 2 over negative 1. And just for my own sake, if you divide by negative 1, you can just swap the signs up top. Dividing by negative 1 is actually the same thing as multiplying by negative 1. It just switches their signs. Okay, so here we move from the numerator, from the denominator to the numerator. This is more often. Every now and then you're going to want to move it down. So let's go ahead and do that. So here, if I wanted to move it down for whatever reason, here I'll take x 4 plus h, and then here I'll add 2. And so notice here, the reason I wrote this problem, is I want you to show that you can have the square root as the first term or the second term, doesn't matter. All you do is whatever sign's in between them, you swap it. Okay, so this is perfectly fine. Now if I do this, up top I'm going to get 4 plus h squared, so that just becomes 4 plus h, or square root of 4 plus h. Here, if I actually did the multiplication, I get negative 2 times 4 plus h, and then positive 2 plus the square root of 4 plus h, which cancels. And then I'm left with the minus 4. And then here I'll have h times the square root of 4 plus h plus 2. The 4's cancel, so I'm just left with h up top. So I have h, although I was like, huh, I'm writing, but I'm writing in nothing. Over h over h 4 plus h plus 2. And here I can cancel out the h's. And then the most simplified form is 1 over the square root of 4 plus h plus 2. Okay. So when you're taking the conjugate, um, it doesn't have to necessarily, you just, whatever sign, if I have a square root, one term's a square root, one term's not a square root, just whatever signs in between them, switch it. Okay.